This is Josh from Team Mandroid giving you the 3 steps of the airbag deployment system utilizing an Android phone. This Android phone built into it has an accelerometer and gyroscope. Both these were important for the algorithm that's built in. Now this is the user interface. It has both a status of service and airbag. The service says that this program is running and can also be run in the background, whereas the airbag status shows that if something's connected to it or not. Now, the 2 most important things to notice are the connect to airbag and debug. The connect to airbag allows the user to choose what airbag to choose from and their code. So if there's a place like a retirement home that utilizes this, you can select from multiple airbags and know the ID of the airbag instead of picking the wrong airbag, and when somebody falls, somebody else's airbag gets deployed and not theirs. So for engineering purposes, our main concern is this debug mode. And the debug mode shows the gyroscope as well as the accelerometer and fall detection. Now, the main thing is when testing was the accelerometer and gyroscope. So when things changed, you can clearly see. And we have thresholds set to notice that if anything passes our thresholds, then it's considered as a fall. Now, what's the difference between a fall and an impact? Is if I wave, it's kind of like 2 steps to go to. So if I just drop it, that's not really a fall. You might get a change in things like accelerometer, but changing like a real fall is, up and down and maybe bouncing like that. And as you notice, that a fall has been detected, but we do not have a Bluetooth set up, so it could not connect to a device. So once again, waving high, it's not reaching the threshold of our gyroscope, but when we kind of toss it up in the air and bounce it, it kind of senses that you've breached both thresholds. So not only is a fall detected, but it's an impact detected, and it also gives the time between fall and impact. So with step 1 complete, step 2 is the next part, is designing the system that would kind of go from fall detection to fall protection. And this was the Bluetooth and integrated circuit. Now, ideally, we want to run a Bluetooth that has a small battery. But for testing purposes, we ran off of a battery that has a 6-volt lantern. Now, we could easily test the system use the system with a 5-volt battery, or even multiple 3.3 batteries hooked up in series. The idea behind it is a Bluetooth will, when receiving a packet, the signal drops low. So we want a flip-flop to latch in a 1 whenever we start receiving a packet. And this 1 would transfer to this transistor, which then transfers to this relay, which will allow this circuit, that all it is a 9-volt battery and a solenoid valve, to complete and open the solenoid valve. So when it receives this pure signal, and I'm going to use this straight connection to transmit, there's going to be 2 clicks. There's one going to be the solid relay being latched, and there's also going to be the solenoid valve. So that's our main idea for behind the Bluetooth. Now for the solenoid valve required multiple stages and multiple designs, and the final design is based off of paintball guns. Now paintball guns use compressed air and CO2, but for electro-pneumatic devices such as solenoid valves, we wanted to go for compressed air. And the compressed air inside of a paintball gun tank normally comes around 3,000 psi. And this solenoid valve can only withstand 180 psi. Anything more than that and it started leaking. So what we used was a regulator and an air port. Now the air port, all it did was open between the tank and the regulator, but the regulator was able to bring it down to 450 psi. Unfortunately, that still was too high for our solenoid valve. The solenoid valve managed to have minimal leaking, but as a drawback, a lot of the air was coming through this hole right here in the regulator. So we wound up wasting a lot of air, but we still managed to get only the air that we needed at that time through the solenoid valve. So this is the setup for Team Mandroid, easy as 1, 2, 3. Thanks for watching.